Hi everyone, my name's Ian Cutress and you're watching an AnandTech video. In this video today I'm going to go through an interview I just posted today regarding Jim Keller being Intel's new hire. He's in control of SoC development and integration, and Intel, some reason out of the blue, gave us a chance to interview him. We've had a few questions come out as a result of the interview, so I'm going to go through it now, and we're just going to give my comments as to what he said during that interview. So here we go. Here is the interview. We've got Jim Keller here. This is Raja Kaduri. He's in this picture. He is currently in Israel, in Haifa, meeting Intel's high-performance core team, the Gesher team, famous for Skybridge. And if we go through the page, let's increase size. So to start with, I'm going through some of the history about Jim Keller. So in the past, we've mentioned that in the semiconductor industry, there are a few individuals that are more than worthy of the term rockstar. We often call Jim a rockstar because no matter where he's in, he tends to shake up the industry, and he's done it many times. That includes being involved in the first K8 Hammer prototypes, as well as designing Apple's A4, A5 mobile processors. He headed up AMD's core development team, so he was covering both Zen and K12. So Zen was mainly Mike Clark and Suzanne Plummer. He was necessarily more focused on K12, but he covered both of those projects, all under the Skybridge concept, and he also co-authored HyperTransport interconnect. After his first stint at AMD, he went to work for Apple, then back with AMD, then he went to Tesla for a few years, working on low-voltage autopilot hardware, and now he's at Intel. As of 6 weeks, 2 months ago, as Senior Vice President of the Silicon Engineering Group. So I did a poll on my Twitter, and at the time, Jim wasn't part of that poll because he wasn't hired, we didn't know, and Raj Kaduri came out top. And when Jim Keller was hired, he suddenly became one of the most requested people. So we've had a few interviews with Intel executives over the years. Most notably, we seem to get an annual interview with Aisha Evans, who's now CSO in charge of strategy at Intel. Intel seemed to like that interview, and then they offered us this one. So yeah, this is me, this is Jim. Over the last 2 decades, Jim has seen a number of pivotal products. He's now management, working in groups that do multi-year development cycles. This is standard in the industry. How long he was at AMD before those products came to market versus how long he was at Apple before those products come to market, then how long he was at AMD again, those products take to market. These things take time. So Jim has been tasked with performance, and now he's under the development, the Silicon Engineering Group. So he's going to be focusing on SoC development and integration, as I've said, and so he works either just alongside or just below Raj Kaduri, and then above that we have Dr. Murthy Rendutin-Chawla, Intel's Chief Engineering Officer. Dr. Rendutin-Chawla has said the company has embarked on exciting initiatives to fundamentally change the way we build silicon, and as a hint of future direction. So I'm going to go through the questions that I said with Jim. Now, to put this interview into context, we literally got 26 minutes with him. It was a very clear stop for the interview. His time is precious, and so the way I deal with Intel is I deal with my side of the PR team, but the people who manage Jim are on a different side of the company, so there's lots of layers in actually to get it to work. I'm glad they did. But yeah, so I had to go in with a set number of questions in mind. Some of these I was able to sort of add subsequent questions on. But it really was kind of a point and shoot. I didn't really know what he was going to say either. He didn't have any copy of these questions either. I kind of told Intel, vaguely sort of what questions I wanted to ask, because they did tell me that, he's not going to be able to talk about product so much because that's all under NDA. It's more going to be about finding out who the guy is. And so we've known about Jim Keller in the industry for years, right? But we've only in the sense of what products he makes, never in the sense of who he is, because he's rarely ever put in front of the press. So this was an opportunity to do that. So I'll start with the first question. For a number of my generation, it was a shock to hear the famous Jim Keller was set and poised to join Intel. Is it like Formula One? Is it like a Formula One driver wanting to drive for Ferrari? Did you expect that Intel was going to be on the cards at some point in the career? Basically, a sort of a why did you join Intel question. So Jim said, he didn't really ever think about it in his career. Some people have asked if he planned it, and he said that the honest truth is he's really just kind of worked on the next interesting thing. So he's had a bunch of interesting jobs. And experiences, and they've all been interesting. When this came up at Intel, he spoke with Murthy, he spoke with Brian Kazanich, he spoke with Raja, around the time that Raja joined, and talked to them at some length, even before he joined Tesla, he said. And then, after Raja joined, they pinged him again and offered him an opportunity. Given that Raja and Jim both worked at AMD, chance for them to resync, even if they were on slightly different product areas. I asked, when the offer came to join Intel, what parts of your brain were firing? How do you expect Intel to differ from the previous companies you've worked for? This question was more to think of, well, if you get an offer from Intel, what sort of products do you think about? And what sort of, everybody knows the core microarchitecture. Is that something you wanted to work on, or FPGAs or automotive, that sort of thing? And he said, well, I'll tell you, I've worked at different places and I've slowly figured out the culture of every company is different. And while he does have ideas about how it's going to be, he's worked out that it's best, to get to know people and get a feel for the DNA of the place, of the people, and the problems. That's an interesting line to say there. He didn't come in thinking he knew what he was going to do about it. He said some places you go. Let's go back again. Some places you go knowing there's a definite plan and agenda, and other places you don't. So he didn't have a good idea about what he would be doing at Intel when he was hired. But he says he had a really interesting opportunity anyway. That I followed up with. So I've heard that some companies hire talent for the sake of hiring talent. And as he stated, he was hired specifically to be Senior Vice President of Silicon Engineering. So even if he didn't necessarily have a plan going in, Murthy did have a plan and a structure in place. And Intel's, Silicon Engineering, there's a large number of teams, and he has the SoC teams and the CPU execution team, and that's a large group, and they have a lot going on. So I asked when the announcement was made, position Intel SVP of Silicon Engineering Group, focusing on SoC development and integration, and it sounded like a very vague title. Can you go into a broader explanation? He was confused with the question, saying he didn't think it was necessarily vague. I said Intel has so many products under the whole SoC thing, so which would fall under SoC development and integration. To me, the title is pretty vague. Is development about developing the product, or is it about the manufacturing and the integration? Is it about working how to integrate the parts together, or is it integrating the platform as a whole? And Jim said, the interesting thing about Intel is scale. Scale of the company is big, and play to drive new technology is big. And there are lots of products for him that are really interesting because the potential impact is really broad. He's playing on a big field, so that's really interesting. He's had quite different roles, and this is a new opportunity for him, and he was quite interested. I followed up with, so the fact that the scale could be 5 to 10x more, would that excite you? And, this was the bit of emotion from him saying, yeah, it's super cool. You don't get an offer like that, coming into a culture and environment. See Intel as this big, monolithic, imposing semiconductor company. But he would say that it's really an engineering excellence focused company. Dan, that's just from his 2 months of talking to people. He says culture is very interesting about how people think about their work and go about it. His plan is to get to know people and talk to everybody, see what's going on. He does talk about scale a bit later on as well. So with only 6 weeks into the job, 6 weeks, 2 months, how many faces are familiar? So we know that within these design teams, there are these rock stars, and there are the rock stars, some groups tend to, you can follow the individuals around and you can see elements in their design as they go around companies. And he said that there wasn't that many. He knows of some of the technical people, either by reputation or through personal, but not a tremendous number. Out of the staff that he directly manages, he knew about 2 of the people, but he hadn't actually met them before, so he knew them by reputation. Out of the 20, he's in charge, VPs of SoC teams, and then there's some technical people, and he said he likes to have a mix of organizationally focused people and technical people. So there's people developing the chain and people developing the product, which is probably a good thing, perhaps not something many of us would have thought about before. So Silicon Engineering is a big group with engineers spread all over. Are you set to lead a specific team for specific projects or help guide a number of teams? Jim's response was, I do all kinds of stuff. There's 2 fun things about these kinds of projects. One is building great products that are really different and successful. The other is working with engineering teams to get people engaged, to make sure the lower friction environment, just to make things go better. It says build better catapults, build better process, build better organization. And these things are kind of complicated. And you can read about it after the After Effects management books. But when you're actually engaging with real people and engineers, some changes are subtle and some changes are not. So I kind of contribute where I need to, and partly I think if I'm successful, then I don't have much to do. But when stuff happens and stuff pops up, his brain's kind of energetic, so he's always thinking of stuff. So there, it's kind of he is there to notice the little things and to jump in and help when he's needed. That's on top of the whole commanding directional sort of stuff that he'll have to do. So I'm quite interested in different levels of this. There's a big direction of computing, like I'm not really a visionary. That's an important sentence. We'll get onto it later. I'm more of a go build stuff kind of person. But to build stuff, there's technical problems and there's organizational problems. And even when things are going well, there's interesting things to change, and there's decisions about when you do an incremental product, when you do a new product, and Intel's big enough that that landscape is complex. To him, the scope and scale of this is super interesting. So I want to go back to this I'm not really a visionary point. This is interesting. So it definitely sounds, even at this point in the interview, it definitely sounds like he's the guy who you want holding the tools, but the guy developing the big roadmaps, that's somebody else's job. Somebody else turns around and says we need a new processor that's 20% higher IPC. It then becomes his job to organize the teams in order to do that, and then get his hands dirty. So anything like corporate direction and structure, it sounds like he's more interested in actually getting his hands on the product and building the blueprints rather than actually building the direction. So if they want low power, if they task him with low power, he's going to go out and do low power. If they want chiplets, or if they want something with EMIB, then he's going to go do that. Obviously, he can have ideas within that, and he can discuss. But yeah, saying that he's not really a visionary means that he might have ideas of where the whole industry is going, but it's for other people to decide. Which, given that he doesn't do many press interviews, can kind of correlate. The people who are visionaries tend to do a lot of interviews. So then I ask, can you discuss if you're tasking with expanding teams or building teams, or are you already analyzing with product roadmaps already? He says that Intel as a whole is quite a large engineering organization, and he didn't walk in thinking that he's going to expand some teams. Intel's always finishing projects and starting new ones, so a lot of work and analysis and architecting and judgment about what should we do on the next project and how do you organize to do that properly. But he's not there really to expand or build teams. He's here to build products, and he thinks that Intel is well staffed. Now, silicon engineering has lots of hires, and he says that they hire good people all the time, and there's a certain amount of people coming and going, but it's normal. But he, likes the fact that Intel's retention is quite high. So now I move more into sort of the hierarchy between the main players that we've been talking about already. So how does that work between you, Raja, and Murthy Rendertinchala? We know that you've worked with Raja at AMD. Have you worked with Murthy before? Jim says that he hasn't. He knows about him because Murthy was COO at Qualcomm, and he knew that when he came to Intel, and he'd had quite a few conversations before he joined. And since he's joined the last 6 weeks, 8 weeks, he's obviously had a lot. He's a very driven character, and he likes to get products done. So far, he seemed to fit pretty well with Murthy. Now, we saw a picture on Twitter of you and Raj Kaduri visiting Intel's high-performance lab in Haifa. And this was the picture right at the top. Here, all these happy, smiling people. They've obviously got a nice product. Maybe. Hopefully. So I asked, what was he doing there? And he says, so some of his teams are in Israel, and they're going to work on, and he was going there to work on roadmap decisions. And then we got a tour of the lab and kind of wandered around, and Raja posted that picture. He said it's just normal work. There's a direct flight, so we can get on, and 10 hours later he's there. One thing when I came into that lab is they asked me if I've ever heard of, the Intel High Performance Lab in Haifa, and he said, "You guys are famous." They are. So then I go on to this question. Normally when we speak about new hire engineers at companies, they often describe that the projects they're working on won't be customer facing for either 2 years or perhaps even 5. If the desire is to implement some short-term projects in the next year or so, do you expect them to be further out or more longer term? This comes from the fact that companies like Intel, like AMD, like ARM, they will have roadmaps for 1, 2, 3, 5, and 7 years. That if you're an engineer that's coming in straight away, you don't tend to work on the sort of 1-2 year projects. If you're skilled, then sure, but most of the 1-2 year products already have everything firmly in place. It's all about finalizing and bring up and manufacturing. If you're that deep of, say, a CPU engineer, you're really going to be working on the projects that are sort of 3, 5, 7 years out. But Jim says he likes the whole pipeline. He's been talking about how we do our bring up labs and power performance characterization work, such as SoC integration and verification, which is what he's there for. He likes examining the whole stack. So we're doing an evaluation of how long it takes to get a new design into emulation, what the quality metrics are. So when he means new design into emulation, that means going from the pen on paper stage to the code it up in an FPGA to emulate it stage. So along with actually designing the products, he's actually looking at the whole process, from going from that pen and paper to how Intel actually emulates the products that they're doing, how they optimize that emulation, then how they finalize certain parts of the core, and then how they bring it up into actual silicon. So not only is he designing products, he's trying to optimize the pathway, which is kind of similar to what he did at AMD with the K12 and Skybridge stuff, and they were dealing with ARM tools and ARM verification. So he's looking specifically at Intel's SoC integration and verification. Now that could be x86 cores, that could be FPGA, that could be ASICs, that could be the new EA6 that they just acquired. And he even goes on to say, we just had an AI summit. Quite a few projects going on. Intel's a major player in AI already, like virtually every software stack runs on Xeon. That could be Xeon CPUs or Xeon PHYs. And we have quite a few projects going on. There's advanced development stuff, there's nuts and bolts execution, there's process and methodology bring up. He has fairly broad experience, but he's a no stone unturned technical kind of person. So while he's not a visionary, he is a perfectionist, which is what you want in a product. If you can tell somebody go build something and they come back and they're a no stone unturned kind of person, hopefully what you get back, as long as it's within a good time frame, will be good. He said that when we were in Haifa, he was bugging an engineer about the cleanliness of the fixture where his surface mount packages plug into the test boards. So that's when they get a chip and it has the bumps and they put it into the test board to verify it. Sounds like it was dusty, and he's he is literally that sort of explicit in his turning of stones. So also we have a super cool lab here. I think he means in Santa Clara in California. We have a 2 megawatt server walls that we use to run our CAD system. So that's the emulation. And he likes all the details, so he's not really a future kind of guy. I think about the future, obviously, because my favorite quote from Ray Kurzweil is, people think about the next 25 years is going to look like the last 25 years, but the future accelerates. And so the next 10 years of computing is going to be kind of wild. I'd agree with that, if everything goes to plan. But he says the next 6 months is going to look a lot like the last 6 months. So I'd say there's creative tension between the day-to-day work and accelerating the future. It's a super interesting problem, especially when you have thousands of engineers working on it. And Intel does have thousands. This is an older picture of Jim. Unfortunately, we couldn't really get new pictures. He's not too keen in getting in front of camera, but we asked. So here we go on. What have you learned since joining Intel? I've learned that there are lots of things going on. There's a high level of technical excellence, and what the team's capable of is super good. Now, bear in mind, he's on the SoC integration and verification, not TMG. So the Intel DNA is to get stuff done, and people are quite passionate about it, so he likes it. There's a lot of changing technology stuff, and there's uncertainty, obviously, in the technical future. So, people worry about that. That goes into, he's not really a visionary thing. But on the whole, it's quite interesting. Have you had time to examine Intel's competitors for the products you're interested in? So we know that every company does competitive analysis. I was wondering whether he had time to do. He had already had time to look at Intel's competitors for the products. So he already knows obviously AMD in the core space, but FPGAs in the Xilinx space, and he's been dealing with Tesla in the automotive. Obviously AI and everything else that Intel gets its hands on. So yeah, of course, technology, you have to think about it. There are fundamental principles of technology. How does computer architecture work and software work, and where does the transistor go? Where did the foundry roadmap go? And then you kind of think about, what do you do? What's the best you can do? What's the competitive landscape look like, and what are the customers' needs? So that space is multidimensional, and you have to consider everything. You always compare what you're doing next to what you did last time, right? That's a super fun idea, but you also have to compare it to what your competitors are doing. You have to compare it to what's the best thing you could possibly do. So there are 3 factors there. It's compared to what you did last time, compared to what your competitors are doing, and then compare it to the best. That's 3 very important targets when you're developing products. Then there's creative tension between those, because the difficulty of achieving different things depend on the lay of the land, and how easy it is, and what the trade-offs are, and everything else. This question is quite amusing. There are a number of elements to Intel's portfolio that must be new to you. This was my understanding that, hey, you're coming into a new company that has such a wide remit. There's got to be something that's new, or something you've not necessarily worked on before. Stuff that you know about, but you've not necessarily kind of like AI NPUs and stuff like that, like Nirvana and what have you. What elements in Intel's range are you looking forward to getting into? What part do you think is new to me? Well, I mean the range of Intel's products that you might not necessarily have focused on. And his response is, well, I'm kind of a computer expert. This was a very nice slam by Jim. Because, if you're going to call anybody a computer expert, you're going to be calling Jim Keller a computer expert. But he also goes on to say he's an AI expert, an SoC expert. He knows a lot about GPUs and software stacks. He's worked on networking. He's worked extensively on transistor level design and foundry. Somebody once said to me that this must all be new to you, but it all pattern matches. So, he's got an idea of how these things look, and it matches previous companies about product stacks. It is complicated, but the details are very interesting, and a number of new faces to who does what is a task in itself. But the thing is that it's new, and it's the next 10 years of computing. So it is complicated, but the details are interesting. That's a good line, because that's kind of, you don't worry about the details until it's time to focus on the details. He knows he's going to have to focus on the details, and he knows that those details are going to be complicated, but that doesn't scare him. That is why he does what he does. That's why he finds it interesting. That's why when I go into a microarchitecture disclosure meeting, and I want to know everything about it, and they have to pull all sorts of engineers out of the woodworks. I know it's going to be complicated, but I know that what I'm going to find out is going to be interesting. Sure, it might only be interesting to me, and the tens of readers that want that specific part, but that's a very important line. That tells you a lot about Jim's character right there. So he goes on to say, we're going through a somewhat radical transformation with AI in the data center and client. So that's not only new to him, but it's also new to the industry. So mechanics of building processes is something he knows pretty well, and the CPU designers at Intel have designed innovative CPUs and have been building processors a long time. Certain details of process design today look the same as 25 years ago, but certain things are outrageously different because of scale. And now this is a good line. The first branch predictor he put into a computer was 2 kilobits of SRAM, a 2 kilobit of SRAM array, and now we probably have 100 megabits, or 12 megabytes, across a chip of branch predictor. Now, how much die error does that take? It's very vague. It's orders of magnitude type stuff. But yeah, I wasn't expecting that little tidbit of information. That's fun. So the expression, a difference in scale creates a difference in kind. I think of a difference between a neuron and a brain, an ant and an ant colony. We have lots of these interesting breakpoints in computing based on the scale situation. Then we have breaks in computing because of things like AI. Discovery of gradients and descent some years ago just transformed the computing model, which has then turned into the Wild West in terms of computer design, and I see newness there. But on the execution side, there's skilled craftsmanship, and Intel has a lot of skilled craftsmen, and some of their tools are sharper than others, but I'm a craftsman of the computer design side. A difference in scale creates a difference in kind. So yeah, I think going between a neuron and a brain, scale of 10 to the 9, when you change your scale by so many figures, it changes the way you think about things. So he's going to have, because he's now working at Intel with a much bigger scale than, say, an AMD or a Tesla, he's going to have to think about things slightly differently, and that also excites him, especially if you're a skilled craftsman. Here's a wafer of Cannon Lake. So, do you expect to be working on products that will be on leading edge manufacturing nodes regularly? Now, you might think this is a stupid question because the answer is yes. I ask that question because it leads straight into this question. How are you involved in how new processes are developed? Now, I knew going into this talk I wasn't going to be able to talk 10 nanometer. 10 nanometer is the hot topic when we speak about Intel, and I know he's not going to be able to say anything, partly because it's not necessarily his department. But I have to do a leading question just to get something about perhaps 10 nanometer to talk about, and what we get is actually quite good. Well, in terms of how do they put metal layers on wafers, no. In terms of how do we define the next generation technology node, optimize performance, frequency, density, power, you bet. So he's not interested in how they design the wafers, but he's interested in the outcome of the design. In the first 2 weeks, we sat down and walked through the metal stack for Intel's 14, 10, and 7 nanometers. So Intel is currently on 14, next generation is 10. They've technically launched it, but you'll be lucky to get hold of it at the minute. And then next generation is 7. And he has lots of opinions about that. So he has a simple theory about this kind of stuff. And as I tell people my opinions, one or two things happen. Either they like what they say, or they correct me when I'm wrong. So yeah, he's going to be quite involved in that. So it sounds like Jim's definitely going to get a chance to put his thoughts into Intel's next generation processes, whether that's a plus or a plus plus, or a different number. Whether people like what they hear or they correct him, whether he's actually going to be influencing any change on that, he doesn't sound as if he's necessarily too confident that, because maybe maybe it's not necessarily his focus, but they definitely are asking his opinion. That's going to be an interesting thing. So I said I'd love to hear your opinions, on what he said about the meta stacks, but I don't think the PR team will let me listen to them. Now I know at this point in the call the PR team are listening, so yeah, there's somebody shaking their head, and I understand the reasons why. This comes back to interviewer technique. I know there are some things he's not going to talk about, and this is obviously one of them. They're not going to let me be fly on a wall to some of these things, at least not until well after the fact, when the process node has died, or even then. But Intel has been a spectacular foundry developer, and that's a space that's super complicated, and they led the world for 20 years. and somebody has a hiccup and everybody's like, oh, woe is me, what's going to happen next? So he's talking about the issues that they have with 10 nanometer. Personally, I'm thinking I know what's going to happen next, fix it and keep going. So Jim is used to the fact that in this industry, process nodes, they sometimes have issues, but eventually issues get worked out. This is what he's saying here. He's not going into any detail about specific issues. Obviously, he's heard about specific issues if he's walked through a metal stack with Intel. But he is of the opinion that it's going to be fixed. And even then, he's going to keep going with what he's doing. I said there's a lot of people interested in that story because we will talk about it a lot and how he fits into that story. He said it's a complicated problem, and again, these things are more sophisticated or more dimensional than people tend to think. Now, a standard manufacturing process for a silicon chip is somewhere in the region of 250 steps. Now, how you subdivide those steps, how many litho steps and how many patterning steps and what have you. And that was a number I heard several years ago, so it could be even more. So there are a lot of levers to make positive steps, and I've successfully designed successful projects in training technology where some innovation is architectural, some innovation is from the silicon, some is at the system, some of it is the software. And it's always interesting to look at the whole palette of that and go and make great products. And again, the special charm with Intel is that Intel is vertically integrated. They play in a lot of different pieces. Intel has set the standard for a lot of the software technology that goes across multiple platforms. And as an architect, I look for the coherence in that space. And as a guy who builds products, I want to make sure the mechanics of doing stuff and the craftsmanship is very high. So he's definitely going to roll with the technology guys. He has rolled with the technology guys for years. And he thinks CPU performance is super important, the graphics performance is super important, density is super important, and he's interested to figure out how to apply it. Now, this sentence, we've had this thing a few times already in this interview. He thinks A is important, and B is important, and C is important, and D is important, or A is interesting, B is interesting. You can sort of get into the mind of how this guy works. He knows that everything is multi-layered, but every layer really seems to interest him. That's important to know Jim as a person, not just as a machine. Though he kind of sounds like a machine, as in he does a lot of stuff. So, like Intel has invested in 3D XPoint, which is a really interesting technology, and now they're playing wireless, and they've arranged components of power. And he says, I think of it as a half a watt to a megawatt problem. So Intel has issues. Intel has projects in the sort of half a watt space, but they also have projects in the megawatt space. So this is embedded integrated stuff, and this is mega data center type stuff. So it's a broad range to get stuck into. Have there been ideas in the back of your mind that you've wanted to do and now that can be realized at Intel? This question was designed because you can't work in this space 20, 25, 30 years and not have a major project that you want to go into. I always think of it's like authors. They know what their next book is going to be, or they've got this big plan for this big project. And Jim kind of says no. He works and focuses on the next interesting problem. He announced that he said that Intel announced that we're going into graphics. And Intel's been developing some really interesting graphics. We've made some pretty serious moves in AI at a scale we can go deploy. But the pillars of our business are the PC and server world, and building, making sure our customers are super happy and that we're doing the next great thing. So he doesn't really have that major. He obviously has ideas for individual things to do within projects, but he doesn't necessarily have a big idea. That I think is interesting. Do you expect to be public facing when it comes to announce future products? And he says he doubts it. He's not really a public person. He likes to work on technology. So he's the engineer that just likes to keep his hands dirty rather than speak to some idiot who writes for an online magazine like me. But I personally hope Intel does bring him out a bit more. I think it's easy to see his passion, and companies that show passion in their product, I think. Get a more positive response. So let's hope Intel does bring them out some more. I asked, in the market today, we have high performance CPUs, GPUs, IP blocks, mass deployed accelerators. What's the future? I know he said he wasn't a visionary, so I also said that I haven't written it down here, but he says the computer world is getting pretty broad. And interesting points again from half a watt to a megawatt. Scale and the scope of engineering team will address quite a few of those pieces. Then I asked, do we have to have another x86, 64 moment? I wasn't suggesting we go to 128. I just mean something as big in scale. And he says, the thing is interesting if you go look at the new applications and the type of data that they're processing and how you accelerate that kind of data processing. So that's important because he's saying it's more about focused compute. It's not about general purpose. The future, the accelerated future is all about specific compute, not about general compute. That I think is pretty interesting. So there are all kinds of people who have problems that take days and days to compute. There are things we'd like to compute in seconds. Yeah, so dedicated processors rather than, say, general purpose. Which kind of begs the question, what's the future of general purpose? Maybe I'll ask that next time. So every once in a while somebody says, well, what happens when computers are fast enough? And he like always thinks really, because again, Ray Kurzweil says he had a graph go from 1870 to today, which is log linear on performance and time. People were saying that it's kind of tapered off in the last 10 years or so. But Jim says, so when people ask me where I think the future's going, well, he says he's happy to follow the curve. He thinks he's going to go on for the curve, the straight line, the log linear straight line. But I'm solving it as a visionary as I can get, because I look at what's the right thing to do for the next product right now, and a GPU product, an AI product, and a client product, and a power constrained product, and a power constrained product. Again, there's a cadence to how he speaks that shows that he is really thinking about this stuff. It's not just stuff that he picks from his mind. It's there already in the forefront. The choices you make with every design point are interesting, and there's better and worse choices, and there's also trade-offs about the customer needs, competitive needs, and expediency. Solving that whole thing is charmingly complicated. So again, this comes back to the thing that he knows it's complicated. He doesn't necessarily have to think about it this second, but he knows he's going to have to think about it, and he knows it's going to be complicated. And that excites him, as it should excite somebody in his position. That's a good thing to know. So then I kind of finished. We were literally on the last 20 seconds of this interview. I wanted to find out more about the guy. So I said, for you personally, what's the best way you take advantage of the newest upcoming technology? Do you want a good workstation, self-driving car, high-end smartphone? Are you a gamer? Does he play Fortnite? And he says he's a kite surfer. So he doesn't know what to tell me about that. He says he's the least savvy computer designer. He had to have somebody to help log him into one of his online accounts. That's almost as bad as my grandmother. But my grandmother doesn't design CPUs, doesn't design SoCs. So he says he uses his smartphone, he loves his self-driving car, he uses technology all the time in a random way, but he's not really a technology nerd, except as tools to go build computers. Now that's fair enough. There are lots of people who don't take their work home. There are people in similar roles to Jim who I know focus a lot on cars. They like the complexity, but apply it to cars, and that's what they do in their spare time. So Jim is a technical engineer. He's just not tech savvy, and that I think that's fairly amusing. This also means for the people who have asked him to get a Twitter account, there's probably no chance he's going to get a Twitter account anytime soon. We're going to have to sort of hang off the word of Raj Kaduri, because he's got a fairly he likes to tweet a lot. So that's the interview. I thought that was a really interesting short talk with somebody who I've wanted to speak to for a while, somebody who's a really important person in our industry. And I know a lot of you have already had comments on exactly what you think of this interview. Some of you didn't like the fact we didn't talk that much about technology. I thought we got a lot more about technology out of him than I was expecting. A few more people wanted me to ask more questions like the last one, find out more about the person. But Jim doesn't really do interviews that often. He's not really used to the whole PR thing. So getting him to talk about that, in order to do that, I'd need to build more of a personal rapport with him. At the minute, he just sees me as some guy who writes for a random website. I would doubt that he actually reads any of my stuff. He might know that AnandTech exists. If he's watching this, yeah, Jim, it was really good to talk to you. Let's do it again sometime, hopefully soon, and bring Raja along. I'd like to talk to him as well. Interesting fact: the first time I met Raja is that I borrowed his taxi in Austin, but that's a story for another time. If you want us to interview somebody else at Intel, I know Intel are keen to put me in front of people who they can get in front of me. Let us know. And I know that Raj is on top of the list. We've also had calls for Murthy Renderton Charla because he's very senior, but the fact he's very senior means he's very hard to get hold of. So anybody else in the Intel stack, let me know who you're interested in and why. I think why is the most important, because if it's somebody who I don't know, then I need to go do some research. And when you've got important faces like the Raj Kaduris, like Jim Keller's, it's all fun, especially when they're comfortable and I'm comfortable and it all goes well. So thank you for watching. If you want to go read the interview, it's on AnandTech, and don't forget to leave your comments. And thanks for watching.